wanted to use my research to help people, and one of the applications I always had in mind is the one on development of artificial limbs. I'm an electronic engineer. I graduated from the University of Bologna in Italy, and in this project with Professor HTRIC, we are going to look at coadaptation in between the user, which is a transfemoral amputee, so lower limb amputee, and a prosthetic device.
We recognize that the success of such a prosthesis does not only depend on the technology of the prosthesis, but also on the tuning of the prosthesis to the user, and that is not trivial because the behavior of the user is very unpredictable, not only due to the complex musculoskeletal dynamics, but also to its voluntary control. How is a user going to organize his coordination when walking with a prosthesis?
So despite the technological innovations, the mobility of the patients is still limited, and the expectations of this patient is very low. So sometimes even very sophisticated prostheses are left on the side because they are not meeting the expectations of the user.
So it's not only because of the lack of technology, the technology is there, but tuning the technology to the user is the missing link in prosthetic success. And that's what we're going to solve. We're building a setup in which we can optimize the control of this prosthesis while taking the human literally in the loop of the optimization problem. So we feel that having this individualized control of the prosthesis makes it very safe and usable in daily life.
Congratulations! You are one of the winners of HTRIC Research Award.
Thank you very much, Ender.
Wow!
Wow, thank you.
Thanks.
So welcome everybody, my name is Wouter Nagengast. I'm a gastroenterologist by training and professor in molecular diagnostics and experimental endoscopy. In our research proposal we have an objective of getting better insight in the pathology of drug distribution. Many years ago we started to image those fluorescent tracers. We developed in-house fluorescence endoscopes. These have specific wavelengths, specific lasers to visualize during procedures the distribution of these tracers. Our aim of this proposal is to get insight in the 3D distribution of drugs used in IBD patients, to get better understanding in are they going to the inflamed tissue, in which concentrations, and which cell do they target. So currently we are treating patients just with standard care. Everybody gets the same starting regimen, same drug, despite the fact that we know that maybe only 30% of the patient is responding to the drug. In this project we are working together with Pieter van der Zaag, who has a lot of experience in getting insight into pathology biopsies and developing new technology to analyze these biopsies.
As a physicist, it was quite shocking to me to learn that so few things are known about where these drugs end. Biology tends to be complex, but here I think we can make a difference by really using optical technologies by which you can measure tissues in 3D.
Yeah. So congratulations, you've won the HTRIC Research Award.
Thank you very much, Marleen, and of course the people who've selected us. Now it's on us to achieve this honor, and on the PhD who will be hired by this.
So I'm Daan Pauwels. I'm a medical biologist by training. I also did my PhD on lung disease COPD here in Groningen. And currently I have a research position at the Department of Pulmonology. So what we try to do is develop a new treatment for the lung disease COPD. So COPD is a very severe and chronic lung disease where the patients have problems with breathing. So in the Netherlands alone, there are more than 600,000 patients with COPD, and over 6,000 people die of the consequences of COPD every year. So what these patients are suffering from is hyperinflation of the lungs. So there's a lot of air built up in the lungs, and because there's a lot of destruction of the lung tissue, the patients are unable to get rid of the air in the lungs. And today there is no curative treatment for COPD patients. So what we propose is a new treatment where we want to use a glue to glue together pieces of destructed lung tissue, so that it takes up less space in the lungs and the more functional lung areas get more room to breathe. That's absolutely what we try to do, to increase the quality of patients, that a patient who is, for instance, unable to walk up a stair, so to walk 100 meters, is then able again to walk a certain distance or to walk back up the stairs and have a better quality of life because they can do more things. The lungs on the inside are very wet. There is a slimy mucus layer on the inside, which makes it hard for traditional glues to glue the pieces of lung tissue together. So therefore we are working on a novel formulation that can function in wet circumstances.
All right, congratulations, Dan.
Yeah, thank you.
You have won the HTRIC Research Award and now you can really get started with this research.
I'm really looking forward to it. Thank you.
I'm a professor in molecular immunology at the science faculty.
I'm a professor in bioimaging and bioanalysis.
We plan to develop a new technique, a new diagnostic technique for early detection of sepsis. So sepsis is the overactivation of the immune system following an infection. And it's a major problem in hospitals. On the top of my head, about half the patients in the hospital die from sepsis. So it's a major problem. And the problem that they're facing in the emergency department is that a good, fast tool for diagnosis is failing.
So we believe that currently if a patient comes in the emergency department, they don't have a good method to detect whether somebody is at risk to go into sepsis or not. So if this technique would be successful, we can then tell earlier, this is a risk patient, this person gets antibiotics, this is not a risk patient, he can go home, or things like that.
The beauty of reactive oxygen species is that this is probably the fastest thing that you can actually measure in a patient. And now with Romana we have the technology to do this, we hope. So this is the hypothesis that we want to test.
Yeah, we are using an optical technique that allows us to sense certain parameters of these radicals. So we measure the change in signal of light based on the radicals that are there.
The strength of the project is that we already do a clinical trial, or we're planning a clinical trial. So if successful, I think it can go really fast. Well, you're still talking in horizons probably 5 to 10 years.
Congratulations, you are one of the winners of the HTRIC Research Award.
Oh, thank you very much.
Thank you.